Okay, so here I'm going to show you how to install Python with the Enthought Canopy. I'm going to show you how to run the parser code. Here I'm just going to quickly open my browser and I'm going to go to enthought.com, and then what I'm going to do is I'm going to try to get the Enthought Canopy environment, which will have NumPy and SciPy and everything which we need to use it. And here I can just get the Enthought Python distribution free, and this has all the packages which we need. So I'm going to go here for 64-bit. Okay, so now that we have the Canopy downloaded for Windows 64-bit, again, you can pick your operating system. We're just going to go quickly install it. And we're going to run anyways. And afterwards, just going to go through the setup wizard. Okay, so here we just are opening up Canopy for the first time, and it's just doing the setup stage. So here, because we're opening it up for the first time, it'll ask us whether we want to make Canopy the default Python environment, and I think so, so we're just going to say yes, and we're going to start using Canopy. Cool. So right here we have the package manager, the doc browser, and the editor, which is what we're just going to quickly jump into. And right here we have all that, and we can create a new file just to test stuff out, and that's about it. So we can run the file. So now I'm going to show you how to run the parser code. So the first thing which we're going to do is we're simply going to go to GEO, so the Gene Expression Omnibus, which is an NCBI collection of lots of microarray data. And we're just going to pick up a random GDS file, which we're going to use as our sample data for testing the parser. And I know of this one, so GDS 1808, which works pretty well as a sample. And it has untreated versus various drug. So what we're going to do here is we're simply going to download the dataset soft file, which is a file with all the gene expression data in it. So we have the soft parser downloaded here, and we're just going to quickly open that up. And Canopy, so because you set Canopy as your default, it should just work as such and open it by default in Canopy. And right here is our Canopy window, and we can just run the file, and from here we should be able to interact and call the function which you see here, parse soft. So what we're going to do is we're going to do parse soft of, and now we have the file name. And it's just very important to keep in mind here that the file should be in the same directory as the soft parser. So here both of them are on the desktop. So soft parser is on the desktop, and the soft file which we'll be using is also on the desktop, and otherwise it will not be able to find it. So they just have to be in the same folder wherever that folder is. Afterwards we're going to just quickly add in the name of the soft file. And now we need to find our control and experimental groups. And the easiest way to do this is just to go back to GEO and just read from here the GDS numbers which we want to work with. So we're going to be comparing right here the untreated with 93 kilocalories per week for 8 weeks group against, say, the glipizide group here, which is also 93 kilocalories per week. So let's just take down the numbers. So here we have GSM 45690 through 45693. So we're just going to set that up as a list, and we're going to do control names equal GSM 45690, close the string, 45691, GSM 45692, and GSM 45693. and I hit enter by mistake. That's totally my fault. I'm just going to call it back with the up arrow, and then we're just going to put out the experimental indices as well. So experimental names equals, and again go back here, find the ones for glyphosate. So here we have 45698 through 456701. And 45698, GSM number first. A GSM just indicates that it is a given sample on a chip. And again, I hit enter by mistake. 6, and finally GSM 45701. And then we close that, and then we close the parentheses from the parse soft originally here, so the parentheses started here. And now just call this, and you'll see that it used one of the weaker corrections, so the uncorrected with 0.01 cutoff. The data probably just isn't that great. And then we can go here just to find our data, so to users, and in the same directory where you put your soft file, it's going to generate some up genes and some down genes. So you'll see that here we have all of the genes that were up expressed, and these are the p-values right here. So these are all positive, and then afterwards for the down expressed genes, the p-values are also positive, but that's only because we took the absolute value. These are still down expressed genes. And you can see the list of both with the p-values, and that should be just the way you use the soft parser. And now you can use these various gene lists for different types of analysis and just study them. So that's the output of the differentially expressed genes.